This is a short discussion of how to find sector area and arc length. So a sector of a circle is just a region bounded by two radii and their intercepted arc. Think of it as a slice. So this is sector ABC of a circle. Where would you see a sector in real life? Maybe a slice of pie, maybe a circle graph, maybe a slice of pizza. We see this kind of thing all the time. So when you were 7th graders, you learned how to find the area of a semicircle. And you also learned how to find the area of a quarter of a circle. For this activity, we want to be able to find the area of any size of a piece of a circle. So any slice of pie that you could possibly cut, as long as that pie is cut from the center of the circle. And the way we do that is using a proportion. What we do is we compare the measure of our central angle to 360 degrees for the entire circle. And the way we use that for the arc length, I'm just going to highlight my arc right there. There it is. What we would do is say the measure of our central angle over 360 degrees is equal to the length of our arc over the circumference of the circle, which is 2 pi r. So we can use a proportion like this one as long as we know the measure of the central angle to find the length of the arc. We can use a similar process to find the area of a sector. So here I'm going to shade in the sector of this circle that's formed by this central angle. And my formula is going to be really similar. Once again, I'm going to have the measure of my central angle over 360 degrees in the total circle. But this time, I'm going to have the area of the sector over the area of the entire circle, which would be pi r squared. So those are the two formulas we need. And we really don't need to memorize anything here. We already know circumference and we already know area. So now we're just comparing the total area to the area of the sector by seeing how that's related to the measure of the central angle over 360 degrees. So let's do a really quick example here. We want to find the arc length and the sector area. Let's do the arc length first. Well, I see that the measure of my central angle is 50, so I'm going to have 50 over 360. And that's going to equal my arc length, I'll just use x, over 2 pi r. So 2 times pi times 5. And one thing to be mindful of here is that what we're really doing is comparing the part to the whole. We have the part of the circumference compared to the entire circumference, 50 degrees compared to 360 degrees. I'm going to simplify this a little bit. And at this point, we just need to solve for x. So you can either simplify your proportion first, or you can just go ahead and use your cross products. My cross products at this point are going to give me 50 times 10 pi equals 360x, or 500 pi equals 360x. Now when I divide both sides by 360, I find that x is equal to 500 pi over 360. So you can just type that into your calculator like that, or we could simplify it to 25 pi over 18. Either way, when you type that into your calculator, you're going to find that x is approximately equal to 4.36 inches. So that would be our arc length. So the distance from x to z along the circle would be 4 36 inches. Now let's talk about the sector area. Our proportion will be almost exactly the same. We're going to have 50 over 360 because we have the same central angle, but this time we're going to have x over the formula for area, which is pi times 5 squared, since 5 is our radius. And from here we use the same process to solve for x, so I'm going to use my cross products. So 25 pi times 50 equals 360x. Then we'll divide both sides by 360. And we could type that in our calculator right now, or we could simplify it. And when you type this into your calculator, you get that x is approximately equal to 10.90 inches squared. So that means that the area of this part of our circle, of this sector here, is 10.90 square inches. So whether you're finding sector area or arc length, your first step is to write a proportion. The proportions for arc length and sector area are very different. The only thing that changes is your formula and the denominator. You need to pay attention to whether you want circumference for arc length or area for sector area. After that, you substitute. So you fill in your values for m and r, and then you evaluate and simplify. Finally, you solve for the value you're looking for, whether that's arc length or sector area, and usually that's going to involve cross multiplication. So this is your 3-step process for finding sector area and arc length.